Now we talk about types of data. Types of data, that means what type of data you have. And every time we think about the data, we think about the numbers. But actually, labels, they are also data. So data has a very broad meaning. All right. Now, first of all, there are two big types of data. Okay. So we talk about the types of data. There are two big or major types. The first one is quantitative, or you call that quant. Okay. The quantitative data is very easy to understand because they are numerical, they're numbers. It's very obvious when you see the numbers. You say, yeah, that's the data. True. And most frequently, or most of the time, it has units. We should say that it has units like one person or two people, three people, things like that, even just like counts. Or you can have like a 1 centimeter, 1.5 centimeter, right, 10 inches and 20 pounds, 2,000 tons, things like that. So they're numbers and it comes with units. Okay, so that's the two things you got to know. And some of the data are continuous. Some of the quantitative data are continuous data. Continuous means if you look at the possible values of this data and you plot that on the number line, and they're kind of like everywhere, so you're going to get some continuous either segments or you get some intervals. So that's continuous data. For example, weight of people. Or then you can have, let's say the lightest person in your sample is I would say like 100 pounds, and the heaviest one like 250. So anywhere between 100 and 250 is possible. Okay, so all the possible values are kind of like spread it out in this whole interval, and it becomes a continuous segment. So that is continuous data. And on the opposite, the other one is a discrete. Discrete means if you plot the possible values on the number line, you get isolated points. For example, counts, like a number of students in math class. Okay. So maybe the smallest one has only one student. I don't know. It might be. And some classes has two, and some has a three. So if you list all the possible values here, then you get those isolated points on the number line. See, there's no way you can have 1.5 students in a class. So this type of data, number of students, usually like a count, they are discrete data. But both of them are quantitative. All right, now other than the quantitative, you can imagine those are categorical. Categorical data. Okay. And some book, they call that a qualitative data. Same thing. So either it's a quantitative or qualitative. For categorical data, there could be numbers, could be, or it could be labels. All right, that's also possible. Categorical data, for example, like a gender, 1 for male, 2 for female. So even things like this, you see the number, you see the numbers, right? When you see the actual data, it shows numbers, but it really doesn't really mean number. It's just the labels. And of course, if you see the grade, which is A, B, C, D, and those are not numbers, those are labels. So you can tell that the grades, gender or gender code, like eye color, things like that, those data are categorical data. So if you talk about the types of data, those are the two major type on that. Okay, now we're gonna dig further. There are 4 more subtype or those are the things very important. I'm gonna test you. Okay, so first of all, it just tells the level of measurements. Okay, the level of measurements, the highest one is ratio data. What level of measurement this data is? Ratio, and the second one is interval. Okay, these two, they are quantitative data, but they're different. For ratio data, ratio makes sense. Ratio makes sense. Okay, so that's very important. Ratio makes sense, and zero makes sense. Okay, ratio makes sense and zero makes sense. For example, the example we just gave earlier, weight. The weight of all the students, and I know the range of the data is between 100 and 250, and so if you get the data, you have, for example, you have a sample of 150 students, then you get 150 numbers, correct? And somebody's weight is 250 and the other person is 125. So we can see, there is a ratio because 250, this guy is twice as heavy as the other guy. So that ratio makes very good sense. And also the count, like 5 people, 10 people. So 10 people is twice as much as the 5 people in class. So ratio makes sense in this case. And also zero makes a sense. Like see the weight, if the weight is 0, that means it's super light, there's no weight. And the count 0, that means there's just nobody. So 0 makes sense and a ratio makes a sense. For in this, if this is the case, then we call this level of measurements ratio data. And of course, you see height, right? Height is a very good example. And of course, weight, okay? And height, weight, and time, okay? Like 10 seconds, 1 minute. So 1 minute is 6 times as much as 10 seconds. So you see that time is a quantitative data and it's a ratio data because ratio makes sense and also 0 makes sense. 0 means just immediately, right? There's no time. Usually time we talk about the interval. All right, now what else? Income. And income is a quantitative data because usually it's in like a dollar, right? Time could be in seconds, okay? Weight could be in pounds, and height could be in inches or feet. All right, what else you can think of? Distance. Distance is also a ratio data because 10 miles is just twice as much as 5 miles, and a 0 mile means you just stop, you start and stop, you didn't do anything. So the distance is also. So all those, they're very good example of the ratio data. All right, now you might ask, what is interval data? For interval data, we don't care about the ratio, and the ratio doesn't make sense and the 0 doesn't make sense. However, the interval makes sense. All right, what is that? I'll give you one example, temperature. The temperature, because right now we're very familiar with the Fahrenheit. All right, now the temperature is 80 degrees twice as warm as a 40 degree? No. If that's the case, then we see, okay, ratio doesn't make sense. What about 0? Does 0 actually mean no? This 0 makes sense, that means 0 means no, nothing, okay? So 0 degree, it just means it's super cold. It doesn't mean there's no temperature. So you can see, in this case, even the temperature, those are numbers, and it comes with units like degree, and we can show that on the number line. However, the ratio and a 0 doesn't make the normal sense to us. And for each degree, like a 20 to 21, it's the same as the difference from 80 to 81, from 72 to 73. See, that's the two temperature, or between 2 degrees. that makes a sense. So the interval makes a sense. So in that case, that's an interval data. All right. Now the temperature is a very, very frequently used example for interval data. And there could be another one. Oh, the shoe size. Okay. Shoe size, you might see the size like a 12, 11, 10, 9, 8, 7, 6, I don't know, 5. Is there any 4? I'm not 100% sure. Okay, so this interval makes a sense. If you go to the shoe store, if you look at the thing they put on the ground, they ask you to measure your foot size, then you're gonna see the difference between each number to the next one is the same. So that's an interval data for sure. However, the ratio doesn't make sense because the size 10 is not twice as long as size 5. All right, and also there's no 0 because 0 you cannot have like a tiny pointing feet, right? So 0 doesn't make sense and the ratio doesn't make sense. However, the difference or the interval makes a sense. So shoe size is another example. The other one is a year, and this year is different than this time. You might talk about the time, say I'm 40 years old or I'm 20 years old. You know, the 40 years old person has been in this world twice as long as the other person who is 20 years old. However, if you have, we talk about the, how do we say the year right now is 20, let's say 2025. All right, before was 2024 and the year before was 2023. Each year, okay, that difference makes sense. So the interval makes a sense. However, this 0 doesn't mean there's no year, or that means, I don't know, it just doesn't really have the actual meaning here. And also ratio doesn't make sense because for the first year and the 2025 is not this many times as much as that one. So ratio doesn't make sense. The year 2000 is not twice as good or twice as long or twice as much as the year 1000 AD. So therefore ratio doesn't make sense and the 0 doesn't make sense. And the year, the way we call that is a very good example of the interval data. All right, now these two talk about the levels of measurements in quantitative data. All right, so if you see the numbers comes with the unit and you can identify, oh, those are quantitative data, and then how do you determine whether it's a ratio or an interval? This one, ratio makes sense and there is actually 0 and it usually comes with the unit. They both come with unit. And the interval, sometimes you're gonna say, wait a second, that only the difference between the two consecutive numbers makes sense. However, that 0 doesn't mean nothing, and also ratio doesn't make any sense here at all. So those are the top 2 levels of measurement. Now we keep going and then we go to the qualitative data or the categorical data. All right, now there are 2 of them, and one is ordinal, okay, and the other one is nominal. Okay. Now ordinal data means you can put the possible answer to this data in an order. There is an order, either from good to bad, from high to low, from happy to sad, or from, but the nominal, you cannot put them in order at all. All right, it just purely just labels. Okay, so this one, I would say order makes a sense. And this one, order doesn't. Order, or I should say no order. Okay, that might be easier. All right, now let's look at some example. If you go to the ER, okay, when something really bad happens, you go to ER, and the doctor or the nurse might ask you, you're in pain, then he or she might ask you your pain level. He will say 0 means nothing, or 1 means very, very light pain, and then 10 means unbearable. So what is your pain level? then you're going to say 7 or maybe 4. For those answers, there's an order to it. So the pain level, okay, so the pain level could be one answer. And the course grade, A, B, C, D. Okay, like A, B, C, D, and F. All right, now those are purely labels, right? So A is better than B, B is better than C, C is better than D, D is better than F. If you convert that into the points, then that's a 4, 3, 2, 1, 0. And even you see the numbers, they are not quantitative. They're still labels, because a 4 doesn't mean it's twice as good as 2. So A is not twice as good as a C. A is really good. C is not that good. Okay, and then this 0, it might mean that you get nothing, you get no points. But anyway, so this 0, it doesn't mean it grows from 0 to 4. So in this case, this is just the labels. So those are the categorical data and it's ordinal data. And there's another one. You see a lot of survey will ask you for the satisfaction level. Okay, usually they ask you to do a little survey at the end of a phone call. They invite you to answer, okay, from 1 to 5. 1 is very unsatisfied, and 5 means very satisfied. 5 is the best. So that could go from 1 to 5 or 1 to 10. They ask you to grade that. Even that looks like numbers, but they're not quantitative. Okay, those are labels, and a 5 is better than 4, 4 is better than 3, 3 is better than 2. So there's an order there. The order makes a sense. Then that satisfaction level is a ordinal data. You might think, what is a nominal? Nominal means just really nothing. It doesn't really mean anything. For example, gender code. Even you have like 1 for male, 2 for female, 3 for no answer or blank or any other things, because sometimes when people fill in the form, they probably leave it a blank, or someone might choose something else. So that's everything else. Even you see the numbers here, there's no order. All right, it doesn't mean that this is better than that, this is better than that. Definitely no. So gender code is very typical. Then of course you're going to say race or race code. All right, and some answers they ask you, do you agree or not agree? So yes and a no, and there's no and then maybe there's one undecided. Okay, there are a lot like types of movies, or I don't know. There could be like a lot of things. They're very obvious. They are categorical, but there's no order at all. All right. Types or blood type. Blood type. Okay. Blood type. A, B, O. Right. We cannot put them in order. We cannot say one is better than another one. So now let's do a quick review. At the beginning, we talked about the quantitative and the qualitative or categorical. That's the 2 major types of data. And also we talked about the 4 levels of a measurement: ratio, interval, highest level ratio, and then interval, and then we go down to ordinal and nominal. Nominal is really the lowest level of a measurement. All right, so that is types of data.